Hey everybody, my name's Steve Richardson and I'm one of Skysiv's API developers here in Sydney, Australia. In this video we're going to be looking at the Python pip package that we've recently created, and it makes creating S3D models a whole lot easier. So to start with, you want to get yourself VS Code. This is by Microsoft and it's one of the most powerful coding editors there are. So once you've got VS Code, there's a few other plugins you're going to need for Python. So if you go to this icon over here, this is the store. The extension store, and you can look at all sorts of different plugins. So I've got a few here already installed that I usually use, but what you're going to need to run Python is this one here. If you haven't already installed it, install that. This just lets you run Python in VS Code. Another good one that you're going to want to work with the SkyCiv pip package is the Pylance extension. So Pylance is very, see, it's still in preview, it says here. It's being worked on quite rapidly though, so it's improving quickly. And this will help with providing the IntelliSense suggestions. So if you're not sure what the input must be, and if it's a string and you're not exactly sure what it is, this will provide you with a bunch of options. Now it's a little bit buggy, as we'll see soon, but there has been a GitHub issue raised for it, and they've marked it as a bug and they're working on it. So if you're looking at this in the future, the chances are they might have even fixed it by then. So what I've done is I've created a folder on the desktop called pip demo. We'll just grab that and drop it into here, and this will open the project. So we can just get rid of that. This icon here is our Explorer. So it's just like looking at Finder or My Computer. We can go to new file and just create a file here. We'll just call this index.py. Once you've installed the Python extension, you'll also have, oh, there you go, you get a bit of a notification about it. You'll get a play button here. So when you run that, that'll just run Python in the terminal. So we can just say print Skysiv, Skysiv. And then if we run play, you'll see the console open at the bottom, and it'll run and print Skysiv. So to get the Skysiv package installed into our project, I'm just going to install it globally, and I want to use Python 3.9, which is the latest. I've obviously got a few versions installed, but by clicking down here, I can select 3.9, and then from within here, because we're using Python 3, in my case it's pip 3, and pip is a package manager. So you can go pip install, and we've called our package Skysiv, and that'll install Skysiv to my computer, not necessarily to the project. If you're used to other coding styles such as NPM, you can set it up in Python to be project specific, but it gets a little bit more complicated. So we're just going to install it globally. You can see I've already installed it here, but once you install it, you should have at least version 1.1.1 or higher. So the first thing we're going to need to do is import Skysiv, and then now we have access to the package. So in this example, we'll just make a simple truss with a metric system. The key things the key tools that you want with this package is probably a model and an API object. Now the API object is what we call the entire package or payload that you send to us, and within there will be instances of your model, which would go against a function, say such as set model. If you use the function set model, you need to provide arguments, and one of them will be S3D model, and that's where you can pass in this model that you've created. So to start with, let's just create an API object and a model. So my interpreter's just gone back here. The one I want to use is this one down here. Yours might be different. Just play around until once you've installed it, you'll see that Skysiv doesn't have the squiggle under it anymore. So the first things we'll do is we'll create an instance of a Skysiv model and a Skysiv API object. So let's start with AO, API object, is equal to Skysiv dot, and you'll see a few different options here that are available from the Skysiv package. And one of them is API object, another is model. this orange icon means it's a class. So we want to create the API object, and then you can open the parentheses and close them. So then we're also going to create a model, which we'll just call model equals SkySiv.model. And then when we open this parenthesis, you'll see that we get some options here. So the way we read this, and you'll see as you put commas to put in the different arguments, that this information here will change. So it takes unit system, which is a literal of metric or imperial. So this is where Pylance comes in quite handy, because if you're using, when you call functions later on, you'll see that there is a lot of functions that you could type in, and they're usually just a few words strung together. If we hit Control Spacebar right now, I'm on a Mac too, then you can see that it suggests imperial or metric here. And this icon here means that it's one. These are the strings that are sort of expected to be passed in. So this is where, if we just click metric there, that'll insert it. But this is where the bug is at the moment with Pylance, is if I open that, then you don't see the suggestion. If I hit Control Spacebar, I won't see the suggestion. It's not until I'm after the quotes that I can get the suggestions. So you can see that sort of played up. So if you just leave it empty for now, unless it fixed it since, and then just hit Control Space and select whichever one you want, metric, and now we've got an instance of an API object and an instance of a SkySiv model. So we'll insert the model into the API object later on. The important things to know are that the API object is created of 3 main components, and let's just jump over to the SkySiv docs, which I have here. We just go up to getting started. We'll go to the request object. So you can see that the request object, or the API object we often call it, is these 3 components. So an auth object, or dictionary in Python, an options object, and a functions array of objects. So first thing we might do is we can just set these 2 things. You probably don't really need the options unless you're a bit fussy about what you're providing, which you can see what is available in the options by clicking it, and that'll show you the different inputs. So this is how you can get all the different inputs that we can accept in the model. So there's a lot of samples throughout the documentation. The model object is relevant to this one over here. So let's just start with setting the auth. So we know that API object is AO, we hit dot, and you can see those 3 things, auth, functions, and options. They're all available. Now these are, if it's got the underscores in front of it, if you're not aware, don't play with them. They're sort of built-in properties of the class. So these, the purple cube means that these are available methods of this class instance. So if we put get, then you can see there's a bit of information, and these are methods that we've defined for you. So this takes the API object and provides or returns a Python dictionary in the format that we expect. Now we don't accept a Python dictionary. You obviously need to pass that to JSON, or stringify that into a JSON string, send it to us, and then when you receive it, you need to pass that JSON back into a Python dictionary. So this just makes sure that the information, if you want to turn your API object into a SkySiv sort of JSON object, this is the method you want to use, because it'll get rid of any of the other sort of strange things that are required in the class to be using this functionality. So we won't use get, but we're going to set the auth. So we'll go ao.auth and then go dot again, and you can see a few different options here: username, session ID, and key, which if you had a look at the auth, you can see username, key, and session ID. So you can have a read about these, what they are, what the session ID is. But for now, we're just going to want to set the username and key. So we'll go dot username, and I'm going to set that to my SkySiv login, which is steverichardson@skysiv.com. Now we're going to also want to include our key. So we can go key, and then you need to head over to the SkySiv website and grab your key. So you can do that by going to account settings from the dashboard on platform.skysiv, and then API access, and you'll find your credentials here. So I'm going to copy my API key from there and drop it into here. And now I've got a valid auth object set up. So it might even be helpful to insert some comments. So set the auth. And then you can do set the options. So we can go ao.options and see what the available keys are. So we can go response data only or validate input. You can have a look at the docs at what these mean. Validate input, I do want that to happen because that means that when you send us your object, we'll run it through a schema to check that you've created it correctly. And if there's any issues or missing data, you'll almost instantly get a response from us saying, hey, this is missing, you need to provide this. Whereas if you don't include it and something goes wrong, it won't find out until it's solving, and then it'll throw an error, which won't use your API credits, but it might just take 10 or 15 seconds. So once the options are set, you can also set functions. We might come back to that later on, or we'll just leave a sort of a marker here. So we'll say set functions, and we'll say ao.functions, and then from there's a method called add. So you can add, and this is what I meant by there's a lot of different functions that you can include. So it's one of these ones, and this is where Pylance will come in handy, and especially as it gets better. Control space, and you can see them all show up here. If I type in session though, there we go. So there's the session function, so I can click that, and again we get that bug. And then after that, it takes arguments here. So see the docs for available arguments. So there's a link here to the docs. In future, I'll add function sort of enums, or you'll be able to just sort of go add SkyCiv function.start session, and then it'll ask you exactly what the required arguments are. For now, you'll just need to manually input them as a Python dictionary. So we want to start a session, and then an example key would be keep open. So if you want to keep the session open so you can return to it with a call later on. But for us, we're not going to do that. It's all just going to be part of one session. So I'll just put keep open false. And we'll want to add some more functions later on. So the way you add them does matter because it adds them to an array. So they will be executed in that sequence. So we'll come back to that and add solve and save and whatnot later on. So for now, we might just jump back up in here. We'll put a note here saying create API object and model instance. And then in here, we'll create a model. And we can start building our model. Or we've already created a model. We'll call this build the model. Build the model. And this is where we can start to add anything you would if you were, say, if you were using S3D. So I might even might just take that there and help make this a bit visually easier. And we could start by creating some nodes. So if we type in model, similarly, you'll see all the available parts of a model. So we've got nodes there, plates, point loads, quite a lot of options. There's the get and set. So get is that same sort of thing I was talking about before with the API object. If you ever want to sort of extract what you've built into a JSON format, look for a get method. If it's there, use that, and that'll strip out any other data that shouldn't be in there. So if we just jump back over to the docs, which is this one, you can go to the S3D model object, and you can see all those keys that we were seeing in the suggestions are here, or here, and you can have a look at what needs to be provided. But with Pylance, it will, and Google Doc strings, which I've included in the package, you'll sort of get this good information back sort of assisting you to fill it out. So if we go add and then open parentheses, you can see here it says it needs an X, a Y, and a Z as integers. We'll just start with 1 at 0. You'll see when I hit the comma that explanation just below the top will change to Y, and it says the Y coordinate of the node. So we'll just put them all at 0. Then we'll create another one. Let's maybe even switch the axis so Z is vertical, just for the sake of seeing how that works. So we'll just go back up here, and we might build the model up here, and then we'll set axis. So we can go model.settings.vertical axis, and we'll equal that to Z. So if you again looked at the docs, you'll find that in there. So settings, so you know it's under the model, settings, and then vertical axis, which takes Y or Z. Now we've got Z as the vertical, we will pretty much just keep the Y value as 0 and just build out a 2D truss. So the X axis will go to 5, then we'll put one at 10, say, and then we know that we're going to, that'd sort of be the bottom row of the truss. We'll go up into the next level and would have a node at 2.5 in the X, and we'll go up to 5 as well in the Z. And then we're going to need a similar one, but this would be at 7.5. And then we're just going to need that final one on the peak, which will be 10 high and located midway along the truss. So then we can add some members. We might again add a comment here saying nodes. We can go members and model.members.add and start adding some members. So this will be, let's look at this. If we go to the end here, we're going to need some, probably just put some IDs there for our own sanity, make things a little easier. We'll go a member from 1 to 2. So if I open parentheses again, we need node 1, node 2, and a section ID. You can see that once we get to fixity, it has equals FFF. So having equals something means that it's got a default value there. So if we just leave that out, then that'll default to FFF. So these are required because they don't have the equals after them. That's the first member, and we'll go, oops, created a few too many there. We'll go from 2, 3, and then we're going to need to go from 1 to 4, and then we're going to go from 4 to 2, and then we'll go from 2 to maybe 5, starting to lose track here. We're going to need 5, 3, and then we're going to need 1, 2, 3, 4 to 6, I think, and then we'll need 6 down to 5. Now what we'll do is before adding any solve functionality, we'll just save it to S3D and we can double check that this is showing correctly. So we might want to add some sections now, so just sort of the profile. So we'll go model.sections.add, and you can see that sections is a little different. So you can either pick one of your custom sections or one from our library. So we'll just go for a library one. And then here we need to include the path. So this is an array of 4 strings. We'll jump to the docs and have a look at what this looks like. We go load section, this here. This is an example of what you need to provide. So this can be found on Section Builder, but we've included a little tool here to help with this. Now, it's not exactly pretty, but it saves you a bit of time and just messing around. So you can go SkyCiv.sections, and in here we've included a sections library sort of thing. So from there you'll see a ton of options pop up, and that's all of our sections. So you can just start typing parts of sections. So I want, if I just wanted a Australian SHS, so a square hollow section, I can go Oz. You can see it's starting to filter out just the Australian things. I want steel. I think it's 350 grade. We'll go SHS. 89 would be before the SHS, so let's go 89 and then SHS. And you can sort of see what we have available here. I'm going to pick a 5mm thick SHS. And this value, if I actually click on this, you can see that it will return this. So this just saves you sort of having to manually do this, and you might get it wrong. And you can just sort of look up in this little sections key what to put in there. So after we've added a section, we need to give it a material ID. So even though it says steel in the section, that's just the shape, not the material. So we'll say that it has a material ID of 1, and now we'll create a material with that ID. So we'll say model.materials.add. So you can do add custom, where you can provide all those options. So in fact, if we just do that, you can see the options that need to be provided to create a custom shape. But we'll just use a default one. We'll go add, and then you can see it takes a literal of one of these. So again, if we just go control space, might be right up the top of this list. Oops. There you go. So we'll pick steel, and that will create us a material. And because it's the first one we've added, that'll be at with an ID of 1. So now we've got, oops, trying to run a script. We've got everything probably except supports and maybe some loads. So let's add some supports. And we can go model.supports.add, and what do we need to provide here? We need the node ID, which will be applying the support at, and the restraint code. So what I might do here is we'll say that it's about the X, it's fixed, but we'll say it's released about Y and Z. So in this case, I'm going to say it's at node 1 because we gave the first node that we passed in at 0, 0, 0. The second one will be at 3, but we'll just provide the restraint code, which is also, if you're not sure about restraint codes, there's a section in the docs here down the bottom. That just explains what it is. So you've got translation and then rotation, and that's XYZ translation and XYZ rotation. Rotation being about that axis. So we can say that it's fixed from moving in any direction, and then personally I like to do the second 3 in lowercase just to make it a bit more readable. So we'll say that we've got our truss, and it's going to be free to rotate about Y, going to be restricted in the X so it can't fall over. So we'll say it's fixed about the X, it's released about the Y, and we can just give Z released as well. Then we can go down here and add to node 3, same thing. We'll just check that there was nothing else yet. So that's where you can start applying. If you're using a spring member, you can start applying some additional values for springs. So we'll just add them, come down to here, and we will just add a point load to node 6, which is, if I've got it right, node 6 should be the peak, the apex of the truss. So we're model.pointload, pointloads.add, and it takes a literal N or M. Again, control space, not that this is a hard one, but just getting in the habit. We'll say it's add a node, and then the node ID. So here you can see that it takes the node ID, it also takes the member ID. So say if we were doing a member and we didn't want to include the node ID, it's still asking for a node ID there, which you can see by the highlight. So you could, for Python, it's you can add keywords. You can just say member with the equals, and then that skips that first one and goes to the second one. And then any other parameters that come after this, you also need to include the keyword. So for our case though, we're just going to apply a node. So we'll say point load at node 6. What else do we want? Position, no, because that's for a member. X magnitude, Y magnitude, Z magnitude. So we want some Z and probably a load group to add it to. So we'll say Z mag, and we'll give that, let's just give it -5 kilonewtons. And we'll say a load group of, or this load group 1, nothing exciting. So this has now created a truss sort of that easily. There's not too much to it there. So we'll just come down to our functions again and start looking at adding some more functions. And let's control space. Ooh. And what we'd want to do after we open a session is we need to set the model. So we can go model set. Again, you can find these in the docs under functions. Actually, if you go to request object and functions, there's a good little list here of the available functions. So typically we have to start a session. That's just the same as opening up a browser and logging into SkySiv. Then you want to set your model. So that's kind of like drawing your model. So that's the function we're going to use here. And then you can look at all the other functions that you might want to do. We'll be doing probably a solve and maybe also a file save. So down here. So let's first just have a look at model set. And you can see that the only parameter it takes is an S3D model. And it looks like this. So we've set a function of this and the arguments. Now, as I was saying before, the arguments at this stage, you just need to provide a Python dictionary. So it pretty much looks like this from here to here. So we can go like this, create a dictionary there, and add that key that we saw on the docs, s3d_model. And then feed the model in here. So you can either just do model or model get. It'll recognize if it's still an instance of the model class, it'll run the get on it for you. So that sets the model. Then you might want to do a solve. Functions.add, and we can go s3d model solve. Tab on that one. Just have to get rid of that again. And then you can look at the parameters that get passed into a model solve. Have a look here. So analysis type, we might just do a linear, and then there's a bunch of other things that you can do, set filters, so you don't get too much data back that you don't need. Analysis type, let's just copy this and drop that into this dictionary. And we'll just make that linear. So we might leave that out for now, knowing that it's possibly not set up correctly, as we just sort of made that on the fly. We'll go down to File and grab the save function. So file save, and it takes a name and a path. So we might just grab them, or we'll just grab that entire dictionary there. Come back into our code, and we're going to move that and do s3d file save. Get rid of the s3d, and then paste that dictionary in that we saw. And we can just give it a name. So we can say pip demo for truss. And I want to save this in my, I think it's my API folder that I have. So once we run this now, we're not going to run a solve, we're just saving it. And then to send it to the API, we've extended the existing request method onto the API object. So you can just go, or we'll say response is equal to ao.request, and you can pass in some optional parameters there if you want to change the transport or version. Otherwise, you can just leave that, and that'll default to using HTTPS and version 3 of the API. Once that's done, we could then print res, and we'll do the first key that is usually in the response called response. And then we also might just include message, so we're not printing too much data out. So this will make the requests with all the data up here, and then print the message, the response. So if I run play on that, first error, a member ID was not provided for a point load with type M. So obviously I forgot to change that back to M when I was demonstrating the member. We'll get rid of that and press play again. So that's looking a bit better. That's taking its time, so it's obviously been sent off. Model's successfully saved, and it even provides a link here, which we could just click, and it will show us our truss. Now that is a horrible looking truss. We've got that member across the middle there, but you get the idea. So we could run the solve on that, and let's just see how that deflection looks. So if I hold S and scroll, yeah, it looks like we've probably, from setting those member ends to fixed, getting a bit of a kick in those members. So you can adjust them as you like. Maybe include that tie through there that we've forgotten. And that's about it for the Python package. So if we come back over to here, you can also just uncomment that, and that will run a solve on it. Then you're just going to have to go through the response a little differently here, and you can extract all that data that you wanted to get out. So that's how we've turned the traditional way of writing out the entire dictionary yourself into a much more user-friendly way, with examples and suggestions sort of built in for Python. So if you have any questions with it or suggestions, you'd like to see a few things added, jump onto SkyCiv.com, log in, and then in the bottom right corner you'll see the live chat, and just get in contact with us. So we're very responsive there, and we're always keen to see what you've created or what other things you might want to see added. So I look forward to hearing from you, and thanks for tuning in.